Okay, this video is going to be on simplifying rational expressions. A rational expression is just a fraction that happens to be made up of polynomials, or it's got x's somehow on top and on bottom. Now this first part is just a reminder of how you do fractions. In order to make equivalent fractions, so to go from 2/5 to 41/100ths, you would multiply both parts by a common factor. So in this case, in order to go from 2 to 40, I have to multiply by 20. If I multiply the top by 20, I have to multiply the bottom by 20. So this is stuff that we did, back in elementary school. But it's been a while because our calculator's been doing it for us since we've done this. So we could simplify our fraction, in other words, go from 41/100ths back to 2/5 by dividing by a common factor. And again, this time we're going by 20. If we wanted to make this more simple, we would divide by 20, and we would be right back to 2/5 where we started. So the same thing is true for rational expressions. You would multiply both parts by a common factor if you wanted to make an equivalent fraction. So if I want to turn 2 over x plus 5 into 4x over 2x squared plus 10x, these two fractions happen to be the same, I would multiply both the top and the bottom by 2x. If I wanted to simplify it, the process is the same, but we use a different word when we talk about division of polynomials. We use the word factor. So we can simplify a rational expression by factoring common factors and canceling. So let's look at an example. Now, I know the temptation on one of these is to just look at it and go, well, 4 goes into all of those, but because of what's coming later, I would rather you factor it. So on bottom, it's easy to see. 4 is a GCF, or greatest common factor, and that would leave me x minus 3. Well, on top, 8 can also be factored by 4. That would be 4 times 2. And that's where the canceling comes in. 4 over 4 is the same thing as 1. So we call it canceling out, but really it's just making it 1. So my final answer is 2 over x minus 3. So same thing for number 2. I know you could just look at it right off the bat and go, oh, well, 3 will go into all of those numbers and just divide by 3. But because of what's going to happen later, I would rather you go ahead and factor it. So on bottom, I'm going to factor out of 3 because it's a GCF, and it leaves me 2x plus 5. Well, the top actually doesn't have to be factored because 3 is already simplified and it's a prime number. 3 goes into 3, or the 3's become 1. So we say they cancel out, but in reality it becomes 1. And on this one that's important because you have to remember it's 1 over 2x plus 5. All right, and number 3, on bottom, I do have a GCF of x. So I'm going to factor out an x, and that would leave in my parentheses an x minus 3. On top, I have 2x. In this case, x over x is what cancels out and becomes 1. So I end up with 2 over x minus 3. Which you don't have to put those parentheses. The fraction bar groups it, but the parentheses aren't incorrect. You put them or you don't. It doesn't matter. On number 4, both the top and the bottom have a GCF of 4. So on top, I'm going to factor out a 4, and that would leave me 2x plus 3. And on bottom, I'm going to factor out a 4, and that leaves me x minus 3. And again, I have factors that will cancel. The 4 over 4 cancels. And my final answer is 2x plus 3 over x minus 3. On problem number 5, I'm factoring again. So on all of these, in order to simplify, you must first factor. So 3 factors out leaves me x minus 4. And on bottom, an x factors out and leaves me x minus 4. In this case, the factor that cancels is the binomial factor, the x minus 4. They're identical, which means they're 1, and it leaves me 3 over x. Okay, problem number 6. This is the first one we've encountered that does not have a GCF. As a matter of fact, the top of this fraction is already as simple as it gets. It's not going to factor. But on bottom, I see that this is squared, which gives me a good indication that it is not as simple as it gets. It can be factored. This is a difference of two perfect squares. It can be factored as x minus 5, x plus 5. And when I factor that, I do see that the x plus 5s can cancel, or they don't really cancel, they become 1. So I end up with 1 over x minus 5. Problem number 7, I have multiple types of factoring involved here because the top has a GCF of 4. So I'm going to factor out that 4. That would leave me x plus 2 inside the parentheses. And on bottom, this is a trinomial, but it has a lead coefficient of 3. So I'm going to factor that with bottoms up method. So I'm going to come down here and do that. Multiply first and last and get negative 12. It's going to give me x squared plus 4x minus 12, which will factor as x plus 6, x minus 2. And we're not finished. Don't forget this step. I had that 3 that I dropped off. I have to bring it back. And then simplify. So this becomes x plus 2, and this is why it's called bottoms up. That moves to the front. 3x minus 2. So now I can go back and put them where they belong. So I've factored this as x plus 2 and 3x minus 2. And now that I see that I've got it factored, I see exactly what will cancel or cross out, become 1. So I end up with 4 over 3x minus 2. And so you can see on number 7 why you can't just look at it and go, okay, well these things have a 4 in common. Because even though there are 4s on these, this doesn't have a 4, but that doesn't mean it doesn't factor. Or that doesn't mean it doesn't simplify. You have to factor it first. So you've got to be careful how you look at that. All right, on number 8, both the numerator and the denominator will factor. They are both trinomials. Let's see, this one factors as x minus 7, x plus 2 over x plus 2, x plus 6. And my x plus 2's become 1. So you end up with x minus 7 over x plus 6. Okay, last one. In this case, we've got 2 trinomials that both have lead coefficients other than 1. So they both have to be factored by bottoms up method. So I would multiply first and last. I get x squared plus 21x minus 100. It's going to be x plus 25, x minus 4. Don't forget you bring back the 10. Simplify. So this is 5 over 2. This is 2 over 5. And bottoms up. 2x plus 5 and 5x minus 2. So that's the top. 2x plus 5, 5x minus 2. And now I have to do the bottom. So 25x squared minus 20x plus 4. Multiply first and last and get 100. That's x minus 10, x minus 10. Bring back that 25. Simplify, so I get x minus 2/5, x minus 2/5. Both of those bottoms up, so you get 5 5x minus 2 and 5x minus 2. Now, looking at this, I have a lot of 5x minus 2's, but 5x minus 2 over 5x minus 2 is 1. So those become 1, and it leaves this 5x minus 2 on bottom, because I can only do that with one set. So your final answer is 2x plus 5 over 5x minus 2. So the important thing to remember when you are simplifying rational expressions is that you must factor first.